Hello and welcome. This is Dr. Jerry Cuomo. I'm here with another rescue case, dental rescue for dental implants. This case happens to be it's an unknown, but it's either going to be a Biomet 3i or Zimmer, or it may be a external hex Branemark back in the early days versus the Nobel Biocare design. All right, so Branemark or Biomet 3i. I don't really have time to show you the film, the x-ray. Today we do have an x-ray of these units. Alright, so first thing I gotta do, because these are mobile, it's 13 and 14, we want to loot these to the adjacent teeth. So I'll back up the video a little bit. Retract the lip out. And you see the mobility there, so now we'll add the composite. We're good. There we go. Now we're squeezing some out. Okay. Grab a hold of the mirror, please. Take that away. Thank you. No, just the mirror. Take the mirror away. Put the shield up. Thank you. Everything is visible light cure here, so we're pushing and we're curing at the same time. Try to get a good seal, metal to metal, hopefully. Now we'll do the lingual as well, but now we know it's going to be relatively secure. So this is step one. Step one, secure the mobile parts so that you can work on it and apply force if needed. We're adding now mirror and material. Okay. So that wraps around here, here, and here. There we go. Shield. Okay. What causes screws to come loose, teeth to come loose if they're on implants? The answer is longevity, wear and tear. Two would be occlusion, the bite. If the bite is very strong, very flat contacts. Over tightening a screw, under tightening a screw, those are some things. Micro leakage, the actual design of the implant, interface, conical connection as we call it today. What's inside right now, we're looking at it like an aqua color. It looks like some form of material, a temporary material. We'll use a scaler and suction. So I'll make sure we're secure. Looks like something moved here. Let's see if there's any movement. We're good. Okay. if we do see extra movement, we'll just add material back as we can. Suction, please. This is some kind of a material. It looks like Teflon. Yes, it is. It's Teflon. Take that out. Okay, so we see a stripped head on 13. For sure, that was an internal hex. Everything all right underneath?
Doing okay?
Okay, I'm going to pass this to you. Out, please. Got it? Okay, turn left on the cheek. Got it? Okay, stay just like that. Alright, let's suction the buccal. You okay? Suction the buccal. Okay, so there are screws. Out, please. And now we're checking the cylinder going in. Looks relatively clean. Next step is to try to dissolve what's in there. So we're going to use a microbrush. Dip it in our tartar and stain remover. I'll ask my dental assistant now for a 2x2 gauze. Great. Put that right underneath in case we drip on it. I want to drip anywhere with this material. So if you feel anything, let me know. All right. Pre-soaking's important. Like big step in the right direction. We're definitely getting debris to dissolve immediately. We're going to also look for the cloudiness of the material. Goes in clear, then it starts to turn a little cloudy. I'm also looking, as I'm removing the brush, the fibrils or the little fibers of the brush to see what I'm taking out of there as I pull it out. I'm just agitating it a little bit, giving it some movement, some hydraulic movement. We've got a mobile situation again, so we might have to resecure. While we're waiting for that, back up the magnification. More blue block out. Okay, triangle, please. Okay. I'm just going to wrap this material right around the back end so it connects. Okay. So their internal hex. Now there's a choice. There's a 0.48 or a 0.048 and an 0.05 driver. 0.405 driver. Let's look at the head of these screws, see if we can identify them from a manufacturer standpoint. It's a guessing game right now, and the X-ray's showing us a little bit of both types. Okay. Long Explorer. Let's go with Endo Explorer, please. Okay, so now we're going to see if there's any movement. Again, through the mirror, counterclockwise would be to my right. And we're just looking for a little bit of movement. Anything that resembles some movement from either one. Alright. Microsuction, please. Okay. This is like a 30 gauge microsuction needle. Goes in, sucks out all the debris, anything that's getting in the way. Fundamentals. Go back in and pre-soak again. Pre-soaking could be as long as 20 minutes, so before we get some action. We're looking, you know, all the action may be down in the threads of the screw and not in the head. So at least we're ruling out the head. That's important. There's two segments to every screw. Is the head portion, which contains the insert for the driver, and then the threads, and they're all different configuration on the threads. Some are V-shaped, some are round shape, and cross section. Some are numbered, and some go all the way up to close to 9 threads. Some of them just 5. Some have a long non-threaded shaft from the head to the threaded portion. Some don't. Today we see more of the shaft and less screw, more emphasis in the shaft itself. I don't know if that's good or bad, because its diameter is less. Most screw diameters are a little over 2 millimeters. 2.5, 2.25. Screw head diameters are a little larger. Still getting material coming up, so we'll continue to pre-soak. Part of house cleaning in the beginning. Screw head cleaning. Wow, we can see more of the hex now. Oh, we might have a little luck of placing a driver. Sometimes food gets in there and debris in the base of the head of the screw, and then you can't seat the driver all the way. So that could be one of the problems. I'm glad no one went in with the rotary. Well, take that back. Looks like they did go in twice with a rotary, and they went right in the middle. So that that debunks that myth. So somebody definitely tried a small rotary in there. Very small one though. They went right in the middle. Might have bumped into a little bit of the hex, but I can see the distinct hex on both, more so on number 13 than 14. If the driver's not seated perpendicular to the head of the screw, you can sometimes strip the head in that regard. So this is some good news for me. I'm looking at it like it's dinner time. Oh, that's where you got to kind of trust your brain a little bit more than your eyes. You have to kind of wait it out. Let the material do what it's supposed to do. Pre-soak. That's why they call it pre-soak.
You're doing great. Thumbs up. Good.
Okay. And just, you know, it's pretty clear now. So let's go ahead and vacuum that out. We're just enjoying the day here. Get everything stay positive. Okay. you know, we could try a little ultrasonics. If we put the tip right in where they put the burr, that would be fine. This way we get a little bit of movement. And then we're going to go in with our drivers and see if we can get some torquing on them. Alright, let me see if we can back them both out. But before I do that, I need a long explorer. I see something alongside of one of the heads. Looks like some material. So I'm going to take advantage of the microscopy and go in and clean that out manually. Sticky material. I don't know what that is. Kind of a sealant material. So this one gets to be soaked some more. There it is. You see that? I don't know what that is. Hopefully they didn't try putting a sealer in there while they screwed it in. Looks like the same stuff though that was used on top of the Teflon. So it leaked through, got to the top of the head of the screw. On 14, I don't see it on 13. Let's see if there's movement in the screw. Yep, we got movement on 13. Alright, that's good news. That one's mine.
They're both of your stuff. They just don't know it.
Come on, 14, you can go too. Be nice. Okay. That's nice. I got one to move. So we go from no mobility to mobility on 13. That's good news. Let's just have a little more patience on 14. Saw a little something binding in there. I'm going to pre-soak it. Yeah, definitely. I don't know who came up with the trust your brain, not your eyes. I don't know. Maybe that was Sandy Koufax when he threw that, you know, that special curveball that nobody could hit. Okay. Why don't I let that soak and I'll work on 13 and backing it out. Maybe just back it out easily. That's when we'll take a driver, maybe, maybe not. And I learned one thing too, on the way out it gets muddy, so you gotta give it a little bit of lubricant as it comes out. We'll leave it in there. A little air entrapment. Good. Oh yeah, that 14 still showing changes in color. That's good news. Okay, so now I'll get my driver. While it's soaking, you just kind of stay open. The dental assistant will just keep an eye on you. I'm going to go ahead and get a driver. Now these are special drivers. And we're just looking to get a hex. Here's a hex driver, and it's manual, so I can feel the area. Let's look at the screw heads of what it could be, alright? So if it's Branemark, it's going to be this one. So this one, we can pre-fit the driver to that. See how that stays in there nicely? And you can turn it, and it sinks all the way in. So that's good. So this one is a PhD 03N driver that would work. We have another driver. This is a smaller company. Just so you see that, see how that spins in there? That's no good. That's too small. Get rid of that one. And then we have some from Biomet 3i. And now there's Zimmer Biomet. So this is an 048. A Rash 8N, so it's smaller. No play, but does seat well. So you got a couple options here. This is nice. That's got a nice fit. So let's see how the shaft is. If the shaft's narrow, then we'll use the narrow one. Alright, how do we hold that one in? Special driver handle. Okay, new gloves going on. We're going to back out the, you know, here's the other thing is you back out the one screw. Now you're going to have a mobile situation again. So I'm going to back it out a little bit. And then just leave it until we can get the other one out. Dealing with 2 screws. I don't want any cantilevering going on in here. Looks like we can go into that one. That's 13. Okay, so now I'm going to go in on 13. This is all hand manipulation. There's no wrench attached to the driver. I'm going to find it, stabilize, go all the way down. Just all feel. Now I'm going to look inside to see if we're turning the screw, so I'm going to mark it just with looking at it with my eyes. Okay, so the apex is facing the mesial, so let's give it a quarter turn, and then we'll look for the apex again, see if it did turn. It's hard to tell with even feel. Making sure that the driver's seated, quarter turn out. Definitely moved. Okay, so that's good. We can continue. Okay, you'll see me move my hands left, right. Now it seats. Put my finger in there, level it, turn. Alright. Keep turning it out. That's a long thread. Very long thread. Okay. So I'm going to switch now to the other driver. A little more narrowness to it. And I'll let it reach inside. To the base of the there. Okay. So that screw is out, all right, but it's inside. We know it's detached from the implant fixture. So 13 is good. Now we're going to work on 14. I'm leaving it in there. It's still acting as a tether. You see the movement on it? Okay. Now let's look at 14 now. Let's see if we got any movement on 14. Again, to the right is transferring the load. Come on. It's still locked in there. I did say I was going to try to use an ultrasonic. I'm going to now. It's a good opportunity. I'll need the long one. Alright folks, halfway done. And then we're home free. Once this one comes loose, we're home free. So we're just going to pick up the other. We have a couple of ultrasonics that we like to use. One has a curl tail to it, the other one is straight. I'm going to make sure we have plenty of water. Alright, thank you. Very good. So this one has some water, though we just don't bind anywhere. I'm going to go right down the middle. Right there. I'm not going to move. I'm just applying, that's it, just vibration. Comes in microchannels. I'm going to increase the amount of, I'm going to increase the amount of vibration. Now I went from 1 to 3, so we're going to see if we can get some more micro movement. If it is just holding by something, we can free it loose. And then I'll insert the same driver back there. All right. Here we go. Same thing, right down the center. That's it. Got a good purchase point. Right down the middle. Out, please. Redirect. Okay, here we go. Now you can feel that vibration. Okay, that's it. That's all we want to do. Let's see if we can establish movement here. Okay. This is the stubborn one.
One in every bone.
Yep. But there's lots of room for a driver, so let's go for it. Okay, so there's my driver. Okay, really got to try hard to seat this straight in. Here we go. Got to be straight. It's got to drop in. Nope, not yet. Change. Okay. Just changing the triangle. Okay, let's check it and see. Okay, so we got an apex right to the mesial, same as the other. This one has been worked over though. Okay, here we go. Alright, the question is, did we get it? I don't feel a strip. I think we got it. Yeah. Okay. Got them both. Alright. So now we just got to back out the screws and clean them up. Find out what to order. If we have the parts here, great, we'll put them in. So that, folks, is how you do it. You don't go in with power tools, you just go in with just some common sense, some solutions, etc. And knowing how to keep that bridge from moving is paramount. Okay. Making sure you seat that driver perfectly plumb with the top of the threaded screw. Because it is still threaded, and unless you do something differently, then you could end up with an issue. So make sure that your driver's plumb. Use both hands, one finger pushing straight in, the other one you're turning. That's why they make these tops spin around. That's okay. So this whole thing's going to come straight out now. You can see it's getting loose. I'm going to go off the screen now and just go direct, because the whole thing is just going to plop right out of there. Just like that. Alright. So the screws are all out. This is where I got to take a look inside the mouth. We're going to identify our implants finally. So what do we have here? Okay. So we've got multi-unit abutments. Okay, very good. Now we got to pre-soak again. So now we got multi-unit abutments, and we got one of the screws is actually fractured inside one of the abutments. So we have a torque wrench. We can torque those in, but we're going to take them out. These are multi-unit abutments, and inside the crown. Wow, this is an interesting case. Okay, because it's a bridge, so these are non-engaging multi-unit abutment. Okay, transferring left. Hang on to that. Put it on your tray. Yeah. Sometimes they come threaded too in the cast too. Let's see if these are threaded. Okay. Push it through. There it is. Okay, so these are set screws. They're prosthetic screws. That we have new prosthetic screws. So let's clean this up. Continuing to clean. Again, all we're looking at is, let's get these out there. Hello. What was that? Oh. Looked like part of the screw is still in this one. We have multi-unit abutments, so I need to get a driver. I have to go get a special driver. Putting everything on hold here for a little bit more, since we've got another little thing to consider. These are multi-unit extender abutments. They have to be taken out, marked, cleaned, put back in, and then prosthetic screws have to be checked. So I'm going to put a cotton roll in there right now. Okay. All right. It should just kind of close on that for now. Bite down all the way. Open. Put a 2x4, 2x2 in there. Close down on that. You okay with that? Mm-hmm. Okay. Picture time. Yep. So okay, we're coming back. Good rescue here today.